So today we're in 6.1. We're learning about scatter plots, and scatter plots are values that are plotted on the graph, and they can be random, all right? But for each point that is plotted on a scatter plot, that represents a specific result of maybe a survey. Okay, so this actually can be really helpful in the business world when, let's say, we go out and survey 100 people. Okay, do you think it would be helpful if I show up to that meeting? Let's say that I'm the marketing person for a company. If I show up to a meeting and I say, all right, guys, I have the results of the 100 people that I surveyed, and I hand them a stack of 100 pieces of paper. You think that's going to help them very much? They're going to look at me and say, okay, well, what does it mean? Well, when we plot, let's say, 100 points on a scatter plot, we can show how the data is trending. We can make interpretations based on the data. We can see where we're doing well, where we're doing poorly. There's so many different conclusions that we can draw based on data that we're looking at on a graph versus a stack of paper. Okay, so that's where it can really be helpful. All right, so hopefully by the time we get to the end of the lesson, you can see how scatter plots can actually be really helpful when we're looking at information. All right, so a really big part of today's lesson are these three terms: outliers, gaps, and clusters. All right, on the first 4 questions on your homework tonight, it's going to ask you for the outliers, gaps, and clusters. What does an outlier mean? It means a value that is very far outside the trend of values on all the other values. Okay, so it kind of falls outside that pattern. A gap is exactly what it sounds like. It's a large space between the values. And a cluster is when data is gathered around a specific value or a close number of values. All right, so we're going to go ahead and write these terms down. Okay, so in example 1, we're going to make a scatter plot based on the data. Okay, you do not have to copy down the table. All right, the table is there. We're going to use the values, but you don't have to copy it down. We need to understand, it's really important that we understand what these categories mean in the first place so we can make sense of this scatter plot. All right, age and years, data used, what does that mean in the first place? We need to understand that. So here's what the problem is telling us. This table shows the ages of 10 adults and the numbers of gigabytes of cell phone data used by each adult in 1 month. Right? Understand that? So each one of these, that person is 37 years old, 30 years old, 32, 65, 53, and that's how much data they're using. All right? So we're going to show this on a scatter plot to see if there's any type of pattern between the age and the amount of data they're using. And it doesn't matter what categories we're comparing. That's what we're looking for. Is there a connection between my X values and my Y values? That's what the scatter plot's going to show me. All right, now, this data is always going to be positive. I'm not going to have a negative age or a negative data usage. So I don't have to worry about the negative part of my X and Y axis. Okay? So this is the coordinate plane. This is a graph, but I don't need the negative part of Y and I don't need the negative part of X. I'm not going to have negative values. So that's why I'm only drawing the positive side of my XY axis. Do you see that? Okay? That's what you need to be drawing on your paper right now. Okay? The X and the Y axis, and then 0 where X and Y meet. 0. This is the template for every scatter plot that you're going to draw. Is your XY axis with a 0 where they meet. Okay? All right, so with every scatter plot you do, your goal is to have roughly 10 numbers on each axis. That will ensure that your values are spread out, but not too spread out and not too bunched together. So how many numbers am I roughly, if it's a few over or above, how many numbers am I roughly trying to get on X and Y? 10. So here's my question to you. Look at the X column, your ages and years. Can you number it 1, 2, 3, 4, all the way to 10? 1 through 10. Could you number your X-axis and get these values on there? Could you number it? No. No, you can't. I mean, do you have values all the way up into the 50s and 60s? So obviously you can't do 1 through 10. All right, so we need to decide what our interval range needs to be. And there is not a definitive answer to this, okay? There's not a definitive answer, but I don't want to make it too big, and I don't want to make it too small. Anybody have a guess what you think your interval should be? Sarah, what do you think?
20, 30, 40.
Okay, so she'd go by tens, and she'd start at 20, which is an interesting observation on that. Lily?
I would do like 25, I guess.
Okay, so maybe go by fives. Go by fives. Elizabeth?
Go by 5.
Go by fives? Okay, so I would go by fives or tens. So everything that you guys are saying, yeah, just let her in. That's fine. Everything you guys are saying is exactly the way I want you to be thinking. Okay? So let's look at the range of our X values. What's our lowest X value? What's our lowest X value?
25.
25 is our lowest X value. What's our highest X value?
65.
65. So we have a range of about 40 in between. Does everybody agree? Okay, so that helps us set our interval exactly what you were saying, either 5 or 10. Okay, so now we have to consider on this first point, is there any point in going 0, 5, 10, 15, 20? Are there any values that will be plotted in that range? No. So instead of starting there, I'm going to start at 20, just below the lowest value. Again, because nothing is happening between 0 and 20. Nothing's happening. All right? So I go 20, 25, 30, 35, 40, 45. Do you see how I set my interval? Now, if you set it by tens, that's okay, but here's my caution. If you go by tens, you need to have a larger gap between your tally marks. Does that make sense? Okay? Because if your gap is 10 on a graph paper, it's like microscopic. It's super, super small. So you need to skip a line and do 10. All right? So, again, you just want to spread out your scatter plot. You don't want it to be all crunched together. All right? So go ahead and finish numbering X. All right, so now let's look at our Y values. You think you're going to go by fives on Y?
No.
No, because what's your range on Y? What's your lowest value on Y?
0.9.
0.9. What's your highest value?
3.
3.5. So going by fives would be ridiculous. It would be like squished all the way down within one interval, okay? So we need to spread out our intervals. Again, our goal is to get maybe about 10 values on the y-axis. Well, I'm not going to go by tenths because then it would be 20-something intervals, and I don't want that. So I chose, well, what do you think you would choose?
Tenths.
Not tenths, because it would be 0.9, 0.1, 1.1, 1.2, then it would be too long. 0.3, you could go by 3 tenths, like 0.3, 0.6, 0.9, but even still, guys, let's not complicate it that much. Let's just go by halves, okay? And on your homework problem, that's probably the interval I would encourage you to use also. If I go by halves, I don't quite have 10 values on here, but I have enough where I could get pretty close to plotting these values, okay? So I would just suggest to go by halves. All right, so now I want you to just extend your lines. This is where your rulers will be helpful, and I know that I'm just kind of throwing it up there. I already had it drawn. Okay, so I want you to go ahead and use your rulers now to make your grid. All right, use your rulers to set your grid. All right, so each one of these sets makes an ordered pair. Okay, so look at the first one, 37 and 3.2. You're going to follow X over to roughly 37. Okay, and then you're going to follow it up to 3.2, and that's where your point goes. You don't have to do what I just highlighted. I'm just showing you how I follow X and how I follow Y up to make my point there. Okay? So for the second one, 30 and 3.3. 30 and 3.3. I'm going to, again, follow it over to 30. This means that a 30-year-old is using 3.3 gigabytes of data, and I plot my point there. You see what I'm doing here? What now? I'm going to do another one. Okay, so pay attention up here, even if you're not done drawing your lines. Okay? Let's look at the third pair now. So I'm doing the same thing for each one of these sets. I follow my X value over to 32. That's my X value, 32. And then I follow it up to 3.1, and that's where my point goes. Okay, so you don't have to do the highlighted part. Don't do the highlighted part. I'm only showing you that for the video and so you can get a visual. Okay, you're only plotting the points. Don't do that tracing thing. Okay, so I've just plotted now the first 3 points from the table. Now why don't you do the fourth point, 65 and 0.9. 65 and 0.9. All right, try to figure out where that one goes. All right, did you plot it here? 65 and 0.9? Yeah. Okay, now go ahead and do the rest of them. Okay, so let's get the rest of them on here. One of them is in the wrong spot. This one. I did it in the wrong spot. Okay, so 59 and 1.3 is going to be right there. Okay, I think 10. I think they surveyed 10 people. All right, so remember, guys, you've got to keep in perspective what we're doing here. This is 10 people and their answers on a graph. All right, so again, instead of me showing up to the meeting and saying, all right, guys, here's 10 pieces of paper and here's my results, I can show that on a scatter plot, and now I can see how the data is trending. Oh, I need one more, a couple more up here. Okay, all right, so I have all my points on my scatter plot now. So now I need to identify my outliers, gaps, and clusters. On number 8, it's going to ask you, make the scatter plot. We did that. Now identify, are there any values that are outside your trending pattern of values? Are there any values that really fall outside of that pattern?
Yes.
Are there? There is one.
30.
That fall? Yes. What is?
Or 1.3.
30 and 1.8. This value, all right, I like to view it as, can I draw a line? And we're going to talk about the line of fit in section 6.2. But could I draw a line that's roughly going to include most, if not all of the points? And if there's a point that really falls outside that line, that's my outlier. Okay, that's how I can identify the outlier. All right, so you could draw the line if that would help you. That is what we call the line of fit that we're going to learn in 6.2. But the outlier is 31.8. What does this mean, 31.8? This is a 30-year-old that only used 1.8 gigs of data. So why do you think their data usage falls so far outside of everybody else's data usage or the pattern? Why do you think this person in particular uses so much less data? Maya? Well, 30 is not old. That's the second person that said 30 is old today. This 30-year-old up here used 3 gigs.
They're old-fashioned.
Okay, maybe they're old at heart. Okay. Okay, their phone broke maybe that month. Sarah? Why else do you think that person used so much less data? Maybe they have a computer. They're not on their cell phone. Maybe they're working. Anybody think that? Maybe they're working or doing something else or watching movies. Or some people just aren't on their cell phone a lot. There's nothing wrong with that, guys. It's actually not a bad thing to not be on your cell phone at
It's
times.
actually human and going outside.
It's not weird. Okay, so that's my outlier. Do you see any gaps? Do you see any gaps in the data? I do see a big gap as well. All right, I'm going to go back and actually erase.
Will it be one? Will it ever be one?
Yeah, it'll usually only be 1 point. What about a gap? Do you guys see a gap?
A big one.
A big one where?
In the middle.
All right, I'm going to draw a line. Do not draw this on your scatter plot, though. I'm just showing you. Okay, I see a gap here, roughly. Do you see any values in this range right here? No, I don't see any either. So we need to identify what value is this point right here. That was a 30. Go back over to your data, your table. That was a 37. So between the ages of 37 and what's this value? This one's right on it. So 50. And 50, nobody was surveyed. Nobody was surveyed. So here's how that could be helpful for a company. If they come back with this data and they say, well, we really want a complete picture. Well, there's a huge age gap right here where nobody was asked. So you could go back out now into the community, into your population, and try to target some responses from that age group. You see how that could be helpful? All right. So to identify the gaps in data, sometimes that gives us an incomplete picture. Maybe people in that age group, their results would actually completely change the results that we would have come to in the first place. All right. Now let's talk about clusters. Does anybody see a group of points where it's all like really clustered together?
Yes.
Caitlin?
37 and 30.
Yeah. Would you agree that it's kind of up in this area, right up here? Okay, so here's what we're saying here. From the ages of 25 to roughly 37, what can you say about the cell phone usage in that range?
It's really high.
It's pretty high. There's a high level of cell phone usage for people ages 25 to 37 for whatever reason. And that's where we can really start making interpretations. Like, why is their cell phone usage so much higher than these people's cell phone usage? Okay? And we're going to talk more in a minute about the interpretation side of it. But on your homework tonight, you're going to make one scatter plot. And then you're also going to identify on this one, outliers, gaps, and clusters. On numbers 9, 10, and 11, you will describe the relationship, which we'll talk about in a minute. And then you're going to read the scatter plot and say, what are your outliers, gaps, and clusters? Okay? So now let's look at the relationship that I actually just touched on. Identifying the relationship of the data values. This is example 2. I forgot to write it. This is example 2. Identifying the relationship. Is it a positive relationship? Are the values trending positive? Meaning, as my X values increase, my Y values are also increasing. Is it trending negative? Meaning, as my X values increase, I'll show you this in red. As my X values increase, my Y values are decreasing. Do you see that on the negative? Okay. For nonlinear, they're kind of forming this like U-shaped. All right. So it's not positive. It's not negative. All right. And then for no association, it's like random. It's just all over the place. All right. So you don't necessarily need to draw these pictures. They're right here in your book. But you do need to understand, can I look at a graph? You have 3 on your homework tonight where it asks you to describe the relationship. Is it positive, negative, nonlinear, or none? Okay. Are you with me? So go back to example 1. Don't say it out loud because we really only have like one shot at this. On example 1, I want you to write down if you think it's positive, negative, nonlinear, or none. Terrell, what do you think? It is negative. As the age increases, you gotta stay with me on this. As the age is increasing, as X is increasing, Y is decreasing. That's a negative relationship. Okay? So what does that mean? Give me an interpretation of that in terms of age and data usage. What does that mean, Elizabeth?
The old people don't use a lot because they don't know how to work the phones.
Okay, we don't know the because, but the older you get, based on these results, the less data you use. Okay? And maybe it's because they don't know how, but maybe it's because they're not interested and they're more interested in building relationships at that point. Okay? So, determining and describing the relationship. Okay? Maybe there's just more important things in life and they're finally realizing it. Okay? I know. It's hard for you to imagine that. All right, page 240. Page 240. Turn in your books to page 240. Okay, look at the table on the left side underneath example 3. What are my two categories on the table? Fat and grams and calories. Let's read the problem to see what it's talking about. The table shows the amount of fat and number of calories in 12 restaurant sandwiches. Okay? So that's what it is. How many grams of fat and how many calories are in each sandwich? That's 12 sandwiches represented. All right? So now what I'm going to do with that information, they've plotted it on your scatter plot. Okay? And they're going to show you that part as well. And they're going to say, use this information, use the relationship. So here's the first part. Describe if there is a relationship. So on your paper, I want you to tell me, is there a positive relationship? Is there a negative relationship between X and Y? Or is there no relationship? All right, go ahead and do that. Or nonlinear, if it's forming a U. All right, go ahead and write that down. All right, what did you say? Positive. There is a positive relationship. What does that mean? That means the more fat you put in a sandwich, the more calories it's going to have. I wish it worked the other way around, right? Because the more fat you get, then the lower calories it is. If it's 100 grams of fat, it's only 100 calories or something. No, the more fat you put in a product, the more calories it's going to be. It is clearly a positive relationship. So you need to write that down. It's a positive relationship. And because there is a relationship between the values, I can make a prediction on a value that is not in the table. So look in the example. How many grams of fat do you expect to be in a sandwich that contains 650 calories? Well, if you look at the table, there's no sandwich that has 650 calories. But I can use that information to make an educated guess as to how many grams of fat would be in the sandwich. I want you to write down how many you think. Look at the scatter plot, look at your table, and try to determine how many you think. All right? So if the sandwich has 650 grams of fat, so look at your scatter plot, you follow it up to a value of 650 and over to where your numbers are trending, okay? And you're trying to estimate how many grams of fat would be in that sandwich. What do you think, Mason? 34, 35, somewhere in that range. Yeah, I'd say 34 or 35. 34 or 35. And actually, one of the sandwiches was 640 calories, and that one was 33 grams of fat. So I know it's going to be really, really close to that value. All right, and that's it, guys. So we basically tried to make an estimate based on the fact that these values were trending in a positive relationship, and that's pretty much everything you need to know for section 6.1.